Well, good morning.
We are looking into several faces that looked somewhat more fresh yesterday. And one very young face. Hi.
Hi, Nemo.
How's everybody feeling? Are you ready, able, and capable to learn something about the event stream? Yeah? It's filling up nicely, Marc Henry. You have some pull on you, hey? No, these are your fans. They don't care about the event stream. All right. I think we've teased him enough. You know what's coming. Marc Henry, would you like to join us?
Yes, certainly. I don't know if my microphone is on already.
It will be in a second.
Okay, but
All right.
we also, Bernard and me, we managed already to educate all you all at the workshop without mic.
See, yeah, the room isn't that big.
Yeah.
But the stream wants to hear you too.
Yes, that is true.
All right, thank you very much. Give a round of applause for Marc Henry, and then we're off.
Thank you, dear Tutu, for introducing me again. I already have my kata tea prepared for today, and I expected much more sunglasses in the crowd, but maybe it was not a too long night after all. This is the traditional hangover talk, so we will start with something really light, the event stream. Last year there was a myth that there was a stream through the forest where some of us might have crossed it. This year I also found someone who actually made the cross. This time we will dive into the event stream. This is more fun, less wet. So, my name is you know, and the contents are, first we will start with the basic concept, just a quick recap. There, I'm mostly trying to explain the new words to you, the glossary. Then we have a quick introduction to the extension points that are new with NEOS 9. Afterwards, I will show how the publishing process works in detail, because we spend so much love in it, and it makes hooking into it really easy because it's so simplistic. And last but not least, we will do something stupid, and I have a little demo, because why not? Hi, Nemo. So, first of all, the concepts from core to from node to graph. So, you have probably seen this chart a couple of times. It was refined over the years multiple times as well, and it's. I think I'm not breaking any news here that we are event sourced and have a CQRS command query separation, but I hope this is clear. But it doesn't matter actually too much to the concepts that we will be following up, like node and subgraph, and that there are node types and dimensions layer, because that can also be implemented in a traditional layer. But later, we will through extensions, we will definitely feel how this two-step process works. Instead of copy-pasting the NEOS docs, we lovely created a DNS sprint into the slides. I will already start going through them, just a quick draft, because we attempted to do is really layered. So at first, and you all know this, we have the node. It's the most fundamental building block. You don't have to read this all right now. I will just explain the most important details. It has properties. It has a node type as a schema, but this is it. There are references are another deal. They are also part of the schema, but they are in the second category. So nodes in itself are just the basic item. The subgraph and the node relations are the things where everything gets really interesting, because a node is only important with relations to another node, and we, for example, have a special kind of node, and this is the root node. This is the first to be explained. In NEOS 8, it was the sites entry point. You already probably have seen that in the node path. Actually, it was one before that. It was just slash. And in NEOS 9, there can be multiple root nodes. They always have to be one type. And from there on, you can just create your regular structure. In our NEOS case, it is the neos.neos.sites root node. And beneath it, there are the sites hanging there with the name and all its contents. So, but for NEOS, we also use the naming for the sites, so we can attach a name for a bucket. But it can also be solved differently. But you already know this from a content collection as well. They have names. In NEOS 9, we refer to them as tethered nodes, because this is the more academic term than auto-created. Auto-created never explicitly declared how nodes should behave if there is a node type change and what should actually happen. It was more, it could also be seen like with node templates they are created when the node gets created, but in NEOS 9 we have a really strict relationship between the parent node and a Schultz if it's tethered. There is, it is guaranteed that they always are together unless you change the node type schema, of course. But for that we have adjustments. So just let that be in mind. This is a strong guarantee. Besides tethered nodes and regular child nodes, we have references. And references are obviously known from NEOS 8. And we implemented them a little more explicit in a different table, and thus we allowed backreferencing. That was already teased at the opening conference. The backreferences were not that easily possible to implement in NEOS 8, but now we have them. They are not super strict. If you delete the node and it was referenced somewhere, the reference entry is either kept or deleted, but as an RP user, you will not know about this. The reference will no longer show up, basically. References can also have properties. This is not yet allowed to be set by UI, but for that you could model relationships like you have a person and another person, and they are befriended, and you want to attach information, how long are they befriended. This is just a really straightforward example, but I bet you can model everything with that, and from complex product catalogs to basically anything. And the last kind of relationship we introduced, this is a new one, or partially new, because in NEOS 8 we only supported disabling of nodes, and your removing was also similarly loose implemented like this. And in NEOS 9 we allow a way more generic concept for marking nodes as anything. It's just a Boolean flag that is put on the node and all its descendants. Yes, I might have forgot to explain these graphs, but I hope they are intuitive. I've seen them so many times by drawing out stuff for the new CR. I will move my node. This is the node. It has a tag attached because it was probably set here. You can identify this by the outgoing relationships, and it will affect the same node and all its childs. Nothing else has to be done from the user perspective. It is implemented in the CR. This really solves the problem of not being able. A node that is disabled will disable all its child nodes. So if you want to query one of a child nodes, you can know if it's disabled or not. You can actually restrict it beforehand. That's where the visibility constraints come into hand, because fine-grained tagging is ideal for allowing to restrict a subgraph's perspective. So Now I said the word subgraph, and subgraph is actually all this combined. The view, the perspective on the whole graph, because you know it is usually really complex in the NEOS, or if NEOS is intended to be used for really complex systems. So there are multiple dimensions, maybe with many dimension values, and you have so many parent-child relations, and it with references and with anything, it really helps to restrict it, and for that we have the subgraph. It encapsulates this really nicely, and if you add to the subgraph that you don't, or you do want to see disabled nodes, it will just filter this out for you, and all its queries like find child nodes, find parent node, find node by ID will incorporate that, and will just not return nodes that don't match that filter. Too many negations. But you get the grasp of it, right? So in the above example, because node is tagged with some tag, if we exclude some tag, we will basically see the graph as just a root and node sibling. There will be nothing else to be queried. It is just a game show if you ever had the problem of working with nested disabled nodes. Subgraphs also encapsulate another part. No, I mentioned that already, and these are dimensions. I will not go too deep into them, but be aware we have a much more we have a fine-grained naming glossary now. We call each point in the dimension space a dimension space point. Don't be afraid of this name. It is just, you can alias it, I don't know. But it is true. It is also really easy to work with them because it's a value object in PHP, and you can target language DE, language and GSB, or even with multiple dimension values. The dimension space allows same or even more complex functionality, or better structured than in EOS 8. This whole guide is really complex, but just as a recap, we allow still shine truths. These are not really shine truths per se anymore because they are calculated at write time, so it is really fast. And we allow peer nodes, so like English and French, and multiple dimension values. I already mentioned that. For really deep information, you can go to the dimensions sections here, or ask me or probably Bernhard any question later. If you want to ignore the visibility constraints and the dimensions, and you want to query the graph on a more larger scale, you're interested in the content graph. There's still some method internal on it, but the basic grasp of it is that you can get a whole node aggregate. And this allows to efficiently work with the whole width of the node. Like you have a node identified by identifier, but it's just not identifying this single node in dimension language, EN, but also in German. It is the same node identifier, that's why we call it node aggregate identifier. They share the same type, they must, and they have the same classification. The classification is tethered or just a regular node. For that, you can visualize it like this. The gray box groups the whole aggregate. You have the two nodes inside here. The yellow is not a real node already because it has no properties. It is just a fallback, a pointer to the node in German. Exactly. If you build something basic, you will not need this content graph because the subgraph already encapsulated everything nicely. But just be aware of it, that it exists, and you. It's just the concept how the CR operates. In a larger scale, the content graph might look like this. We have different colors for different dimensions, and everything is accessible. The root, you might notice that, is a special case. It occupies, I forgot. It either occupies all dimensions or it covers all dimensions, but it is always a variable in every dimension, otherwise it would not be the root. Exactly. Now I will go into the workspaces chapter because, truth be told, we don't only have dimensions, visibility constraints, we also have even another perspective to be really broad, and that is the workspaces. You already know this because you work with Live, and then probably you have a user account to edit the website in. And in EOS 9, this is implemented in a different way than in EOS 8, and all the concepts we have had before fit on this workspace model too. So each workspace encapsulates this, but you can also go through all workspaces and have each workspace has obviously the same dimensions in the configuration, but they might contain different nodes. I will not go right now too deep into this because regarding the publishing process, I've prepared something else for later. And that would be it for the concept. So, back to the slides. Now it's time to talk about extension points, because they are really important. I did a small phrase, a word play, not a word play, but I referenced AOP because you might wonder if this is still relevant with EOS 9 in the content repository core, and to be honest, it is not. AHP was not intended to be used with EOS 9 because it's a library. You cannot hack into every point. That on one side, it makes extension really fine-grained, and it allows us to guarantee that the system works incredibly reliable. But you can use other points to hook into the system. We have prepared a few. So at first, I want to share this simple example just to get you in the right mood for working with events. Imagine we have an event stream. This is the time flowing from left to right. And there are existing events, like just a node which was created. We just have named it a document node, and it has a title. And then we want to issue another event, node properties were set. In EOS 8, it was just a set property, and you could hook into this with a flow signal. This is basically also connected with the same AHP in the back. That's why I referenced it. The event will contain all its properties and the node be targeted. It's also important, or just good to know, all events implement in PHP the event interface, just that you know, so you can look them up easily. And they are defined in the content repository core, but not extensible, obviously. We have a discrete amount of commands and events. You cannot extend them because we wouldn't know what to do with that. If you have, if you want to extend something, you need to open up an own event stream or use traditional OEM to store data. In the next slide, I will just keep the node properties were set event in mind. And the next slide, I will show you that we have projections. This is the most basic item that is required to work. We always have to ship one, and that is the content graph. These are the subscribers that get the events, and the goal of the projections is that they have to be side effect free, and only be deterministic based on the events. So step by step, they will go through the events and just build up the state in database or memory or wherever. They do come with the complexity to track everything. So in the first example where we just create a node and set a property, you might think it's really simple. We can implement that. It really gets complex if you want to find out at any point if a node is a child of another. This is basically impossible to re-implement. Not really. We have the, as example, the content graph and document UV path projection. You can just copy those. But we will go in the next example to show you what is a possible way to hook into the events. So because they are so low level, it comes with a lot of work to implement something. They do have because they are so low level, they do have the gain that you can always replay them. If you only have the events, you can replay them up to state X, and everything is fine. You don't have to worry about anything. With catch-up hooks, this is a little more different because sometimes they do side effects after all. In the most basic case, sending an email, though we want to, in a future version, we want to guide you to use async processes for that, because if you do too much, the process will obviously go slow. But for that later. Catch-up hooks are the concept we built above projections. So the projection, let me go back, it has a state, and it has apply. It's really simple, you get the event and you build the state. In the catch-up hooks, you can access the state of the projection. In the case for the content graph projection, you can query the graph for every node and check if the property was something set before and how it differentiates now, and or where does it reside in the tree. And you're always guaranteed to have the current information from the graph. It is also important to be noted that it can only be invoked around one projection. Otherwise, the guarantees are really flash. We don't know what happens if you replay one projection and then other is out of sync. Then there is no there is no solution for that other than restricting it. Now, it can greatly be used for cache flushing or for the asset usage. These are the cases we have. You can just look into the catch-up interface and see where we implemented it. And for setup, it's also be noted that we either have to build a custom indexer if the content graph is already at a position 1000, I don't know, where you already have nodes, because otherwise you would need to reset the content graph and replay it up. I feel like this is, for me, really self-explanatory. Danny also knows this. I will show an example. Right here, we have, I took this from just the asset usage, and we have two hooks, on after event and on a pop event. I will focus on the on after event first. It is right invoked after the event was issued on the event stream. We can still see the basic schematics right here, event instance. It was in our example a node properties per set event, as we already remembered, with the title moin. And if you wonder what is the event envelope, it is actually the raw structure of the event, how it occurs in the database. We have more metadata considering which date it was issued, which is its technical unique event identifier, and what is the encoded JSON serialized payload, and even more information. But for the most cases, you want to work with the deserialized PHP value objects and these are the node properties with set events. It will already know all the properties, and it is type safe. This will flow through the first parameter in event instance. Then you can check which case it is. We have seen before that we also work with node accurate with node was created. This is the initial node creation, but we now want to focus on the node property setting. And then I invoked a custom helper update node. It requires 3 parameters. We will just focus on workspace name and node accurate ID. The event knows that as we already know, and then we can fetch the node from the graph and add it to some indexer and update it. This way we could probably track properties or the anchor stars of a node and do some efficient lookup later, or we use it for the asset users, for example, where we have to know when a node used an asset and what was its current hierarchy at that point. Or for cache flushing, where we have to clear all the scanlins after we deleted a node, or similar reasons. It might be also interesting to know that we have a clever way of working with removals, or because naturally you wouldn't be able to query a node that is removed, and for that we have the onBefore event. It will allow you to query the content graph before the event was issued, and this obviously allows you to check, oh, there's a removed event coming. How about we query the graph right now, and later it will be removed, but I can still do some tasks. On after event, this wouldn't be possible because the node would already be gone. Yes. A second hook are the command hooks, and they are intended for hooking into the command process. They are totally different from the previous hooks we saw because they operate on the after the command was handled and the events are generated. The command hooks work before that and completely around that. So they allow you to either already return a totally new command or modify that before the command was even really issued to the content repository. It's a really early layer around it. It can access the content graph as the catch-up hook also. Has to be as limited as a projection. And we see a simple interface of it right here where we just can get a command interface on before and return another. On after handle, we have a similar contract where we get in published events just a collection of the events we already have seen in the catch-up hook. Yes. An example would be custom constraints, or also ensuring that for a certain node type, an identifier is always unique among its siblings. A simple use case for that would be obviously HTML anchors, where you don't want to have the same anchor on the same page. Or right here we have, I've basically taken this from the example for Neos forms, where we also have to ensure that identifiers are unique. This is a solution to easily to be guaranteed to hook into the process, and you don't have to rely on the editor doing that. I don't think it looks that complex. It's just a little bit of command and getting the properties out. To those who were at the workshop, you already know the graph of it. You need to get the content graph, you can get the subgraph, you have the node, you can check if it's of type special type, and then you can do your custom logic to adjust or modify the identifier. Maybe it's already a qualified identifier, and then you just return it and reissue this command with a different set of properties. You can find an example is in Neos form. Maybe I will also post this, but it's probably not working. There's a lot of component code. The command, for anyone confused, is the attention before the event was issued. It looks a little similar to the event because the event in this case is not that complex. It is just the aggregate ID and properties. Though in the command we work with the unserialized raw PHP object as properties, while the event has to be serializable. And the command is just an unvalidated intention. The node aggregate ID might not exist at the time. If I'm a stupid programmer, I will just attempt to set up properties on a node that doesn't exist, and then the command handling will fail and will just not respect that intention. While the events are ensured to work, they are already validated, and the node exists. The properties were set this way. This is what happened. The command can fail. So, I think we already good on time. How many time have I left? And minus 5 minutes. Why? Minus 5 minutes. Okay. Now we're getting into the really interesting part. It's about publishing. Was this serious minus 5? I looked on the clock. I started quarter past. Okay, I will make it a little quicker. We have something as similar as changing the text right here on the website. And this might seem really simple, but I'll also click the publish button. This makes it a little more complex. What is happening? You might ask, but maybe you will not, because it is really complicated. I don't know if we should really go through that as all, but I did prepare some really nice slides. So at first, we want to edit this node. We have seen the similar screen already. And the real first step to edit a node is not actually edit that node. You know that we have workspaces. So you would have done this in the user workspace. For that, we fork the content stream and do this in the user workspace. The second step then is to, during publishing, to modify the live workspace. And we do this by taking the event we had on the user content stream and putting it on live. So far, so simple, right? But the question is now, what do we do with the user content stream? It is a little odd because it has the same event now, and it is technically diverged because the events are not the same. They are just similar. So, without going too much into detail, at the end, we found a really nice abstraction, but I wanted to go with you to the process how we did that. And the first idea was that we were in a hassle, as we cannot remove events from the content stream, as a content stream is always append only, we would have to start something new. And then there's the question, how can we start a new workspace if we already had that from the user? If this is not possible, user Danny already existed, and we cannot. We would need a technical identifier where we really place the content, and for that we have content streams. So instead of actually always just referring to the workspace internally, we always refer to the content stream. So we still have the stale content streams. At some point, they just lead to nowhere and stop. But we can create a new content stream. And we have a clever way of linking that back to the workspaces. And that is done by a separate content stream. This is for workspaces again, where we first have a signal where the workspace was created, and we attach that to a certain content stream. And later, every time when something changes, we update the content stream. But the workspace name stays the same the whole span of life. Just its content stream can always change at any point during the publishing, for example. In this example, you can see how the events are correlated basically from the content flow and the workspace mapping to content stream flow, because every time we create a new content stream where we start editing or where we publish, we issue a second event so that we can map the workspace to the content stream back. This is not your concern anymore, luckily, as we simplified the workspace handling and moved the workspace to the nodes itself and the content graph and subgraph. So normally you always need to only be aware of the workspaces, but internally it looks a little complex. In total, the full publishing process looks like this. Let me walk you through this one last time. First, the first edit, we edited a node. And for that, we had to have a content stream fork. I used this little fork emoji. Then we decided to publish this change on live, and we just take that event and put it on live with a different workspace name, obviously, because it's now on live. Then we say the content stream was published, and we fork a new one and say that we we fork a new content stream for the user, that is the green one on the top, and we connect it with the published event, so we still have the information where the current content lives. And then we can repeat the process on putting events on the green arrow again. This might seem a little complicated, and I didn't have time to fully explain it completely. But the basic information is that you don't have to worry about this too much, because if you're ever interested in live, you can just listen to the events on live. Whenever they will be relevant, when they were put on live, either by imported directly or because they were published on live, you will just notice it. You can just ignore any temporary changes, and this makes interfaces like the command hook or the catch-up hook really, really simple to use. For example, if I have the intention to note if after a handling, a command, if I publish command, this would be a publish command, did change a property, I can look in the published events and do another operation afterwards. Yes. Any questions? Christopher.
Okay. So in the docs, I didn't really. It's not completely, which are really good. So kudos for understanding. But I didn't get really if the commands for the rebase part and everything are reapplied and can fail. What will happen? What is happening if a command cannot be applied because the node was removed in between? Talking about rebasing, which you didn't go into, which is even more complex.
Mm-hmm.
Maybe you can repeat the question quickly for the audience at home.
Christopher is wondering the right question about how we solve the rebasing and publishing with no deletions. This is excellent, because we spent, before the release, I think 3 weeks on that, by fully re-implementing that. And we did a clever solution by actually not removing the nodes, but we just tag them as removed. And do that, we can still apply a rebase, and the node will still exist. And I will go in depth with this later, but keep in mind we took 3 weeks to implement that. And it's a garbage collector that basically cleans the soft removes node up if there are no usages left. It is not, there's no time to explain it in detail, but we solved it.
Well, thank you, Marc-Henri. Well done. We got a question from the audience anyway. We haven't got any in the app.
We don't have any other questions. That must mean you've answered them all.
Or I just confused
Or
everyone.
you confused them all, or you were in so deep that they wouldn't even know what to ask. So either way, no questions. How do you feel about the fact that Taylor has her master's back?
Good.
So this is Taylor
Totally
Swift content.
unrelated.
All right, thank you so much. Now, everybody hurry, hurry. The next talk downstairs is happening like now. We'll just go seamlessly into the next talk to catch up the delay. Another big round of applause, please, for our one and only Marc-Henri.